Okay, I think we can slowly start if there will be more people, so we'll just cover organizational issues first. So welcome to our second class. An announcement, as we said before, next week we will have no class. I will be away from the university, so we'll see each other in 2 weeks. So week 4 we will meet, but week 3 no class. So there will be some homework, some exercise for you to do, but I hope things will just run smoothly. With any questions, please let me know. If anything on the technical side works or on the side of understanding of key concepts, but we will not miss any further classes due to any holidays as well. So I don't think we will have to catch up. The content which we'll cover in 14 weeks will be there, and we'll cover more than the majority of the courses running, for example, on Mondays or on Thursdays this semester. So we'll very much on target with covering the content. So yeah, no class next week. Then firstly, the Moodle space is now ready. You can find this course, and I hope that you will sign up without any problems. I did not put any code for enrolling, so self-enrolling should work. If any problems, let me know. I see that already some people started enrolling, so I hope that this works for everyone. We will put links, resources, videos, technical presentations here. Today we'll have one technical presentation, so I hope that people will be able to follow it either online or offline later on, so there will be all covered, like with these steps which you would like to do later on. And there will be some home task that we will review in our week 4. Then there is the link to our Highbox resources for the course. The link is general all my teaching, and then you choose our course principles and applications or machine translation. And here, as you mentioned, sorry I did not send an email, even though I promised. Yeah, so assessment is specifying what you need to do for assessment, something we reviewed last week. So this is basically tells you that the assessment is due, I think, 4 weeks after the end of teaching, which will be, I think we finished teaching in July 25th is the end. So basically it will be around the, as I understand, the 18th of August, the submission date, and all the specifications, possible topics, like topics for inspiring yourself with investigating things further, and your own idea for experiment is very much encouraged. But so you can just use some of the links here, some of the ideas from these different areas, different things that we will cover. There are grading criteria here. We will come back to the assessment later on, but the specification of assessment is now online. Right. So we will try to look into some of the issues about how machine translation systems are built. So I will more or less cover today some examples that present different ways how machine translation architecture impacts the type of errors, the type of problems that are created. So hopefully it will be interesting area for you. And there is kind of some interesting work which kind of we can later on do as an example of evaluation of the machine translation quality, and I hope that this is also important and interesting for you. So that's the resources for this week and for the next week. So I'll be putting some of the slides already there, but it's very much the idea which we will be covering within the next few weeks until we reach the collaborative project. We will do a collaborative project on the controlled language and designing controlled language rules, and there will be time where we work individually and then we put things together and try to reuse our results for further expanding the languages for which we evaluate the systems. So this is the resources on the Moodle platform, right? So that's pretty much everything I want to say on the administrative side. Any questions about course organization? So if you search on Moodle for this like course code or the number or whatever, and then try to self-enroll, so it should work theoretically. Yeah. So there is maybe ID. Okay, yeah, thanks. Okay. So yeah, theoretically, people also not taking this course can get in, but yeah, so we don't mind. I hope we will work fine. Then today we will, apart from doing some investigation into examples of machine translation and doing some theoretical work, covering some slides, we will also try to set up the technical foundations for evaluating of machine translation quality. And I just wanted to briefly check already your background. I know some of you come from mainly humanities courses and humanities background, and this technical stuff will not be like rocket science, but some of you already started coding, started learning the programming scripting languages like Python or some proper languages like Java, maybe C++. So I just wanted to briefly check if anyone had already worked with platforms like GitHub. You worked, yeah. Anyone else? So you worked, yeah. All right. And Google Colab? With not yet, yeah. So right. So we'll see these platforms. So it's basically something which would allow us to run the code which someone else has written for us, has prepared for us, in order to, for example, automatically evaluate the quality of machine translation. So it's one of the applications what we will be looking at today. So BlueScript, so which is the most famous way of, like earliest way from 1990s of getting some score to say whether machine translation is good or not, or compare different outputs of machine translation. So we'll try to investigate this this side of things. Yeah, so that's yeah. With requirements, what you need to have. I'm really happy that nowadays it's much easier, because in the like maybe 10 years ago, I would have to spend maybe the whole class on making sure that for the technical part of this course, things are run okay on your laptops, that you have all the components installed. You have, for example, Anaconda, you have Python, you have the environment, and that kind of took so much time. Nowadays, everything is in the cloud, so all you need is to get a Google account. I think pretty much everyone has Google account, so shouldn't be a problem. If you don't have a Google account, please get one. And then you need to log into your Google account in the browser where you will be clicking on those links, right? So I think that's pretty much what the requirement is. Yeah. Secondly, something which we covered in the first part, not everyone was in the first part, but I will set some tasks which would use the Sketch Engine platform. And to access Sketch Engine, you just simply type the sketchengine.eu. You have the Sketch Engine. I think I'll add the link just to the list of resources here. So this will be the Sketch Engine link for those of you who haven't worked with the Sketch Engine or just wanted to access it quicker. So create link, and I hope. So could you raise your hands who already worked with Sketch Engine? So okay, half people kind of still will kind of cover the introductory part. For those of you who haven't worked, so you just click on this kind of, if you reload thing, so URL, you have the sketchengine.eu link, and you click on it, and then there is this login button. So I just need to get sign out and show you the procedure. So when you're clicking onto login button, it will show you this screen. For those of you who like, it's kind of a little bit confusing and tempting because Google is like suggested as the first, but don't click on your email address and password. Instead, click on this institutional login. So you will here, after clicking on institutional login, you need to type the word Heidelberg and select our university, and then log in with your usual username and password in our. And that's pretty much it. So it gets you into the dashboard of the Sketch Engine. So what we will be doing today, I will show you some exercises for the next week. It will be working with the data sets which we download from the parallel corpora. Yeah, so you need basically to get access to this like second button, select corpus, and then in advanced button. So we will try to find some corpora which contains parallel text. And one of such corpora is Europarl. And here you have Europarl in many languages. So we can start with English and see if you need any other languages. And the beauty of this is that it has the material that we mostly need for our evaluation, for running our blue script, for our evaluation of the quality, because we will tell kind of the story, the methods, how we evaluate the quality automatically, what is behind the assumptions for automatic evaluation. And very often, in most cases, for evaluating the quality of machine translation engines and comparing different machine translation engines, you also need a gold standard human reference translation. And this is basically the source of finding good human reference translations, which are checked by people, by professional translators. So, for example, if you select English, then the button which you will be using is this button parallel concordance. It's only available if there are translation equivalents, if there are other sentences which have been checked by human translators. And you can add several languages. So we have German, but you can have French or so any European languages, Italian, for example. So we have Italian here, and yes, we can just try to create some set, some evaluation set, something which we can investigate. Yes, so how some difficult expression is used. Look after, for example. So what are the translation equivalents of look after, and if different machine translation systems deal well with this linguistic phenomenon. So this is basically the operations which the steps which we will go through. And so here are some data sets, some translation equivalents for so some sentences where we have these concordance lines, but aligned language by language. And then what we also will be using in this exercise is this button, which is download. Yeah, so to evaluate the quality of translation, you will need to get these data sets, human reference translations, onto your local machine, and then maybe upload it into the cloud. So we'll kind of work with this pipeline, but for this class and the next week, you will be, so you please make sure that you can log into the Sketch Engine platform, and then you have on your Chrome or whatever browser you are using, you log into your Google account. So you create a Google account. Usually to check if you are logged into your Google account, you can type something like drive.google.com. If you are logged in, so it will take you to your space with 15 gigabytes of files. Yeah, but if you are not logged in, it will ask you to log into. So please log into your account, and that's something which we will need for our class today, right? Okay, then can I ask if those of you who haven't used Sketch Engine before, were you able to, on your laptops, to log into this sketchengine.eu? Yeah, so it worked. Yeah, so I think that then we have everything set for our class. Good. So then what I wanted to do today, maybe we'll move to this automated evaluation of machine translation quality a little bit later. But firstly, I would like to say a few words, like in this presentation mode, it's still like our first full class, so without major administrative material to cover. So I would like to just say a few words in terms of the goals for the different aspects, so introduction into machine translation, so and different ways how machine translation systems are built, and what we will be doing, yeah, and for what reason. Yeah. So firstly, machine translation, like there is a definition, is attempt to automate all or part of the process of translating from one human language to another. So one of the possible definitions. But if you try to translate some of the things with different systems, you may notice that you get different results. And I tried this like for a number of years with I think starting from 2007, and you may notice that things really got much better. Yeah. So if you have this French sentence translated into English, for example, yeah. So the earlier systems tried hard, but the quality was not so good. Yeah. So machine translation refers to the strict sense is fully translate a text with one or more computer programs without a human translator has to intervene. So this is how it sounded like back in 2007 or so. So this was quite early days. Then there was another school of thought in machine translation, which believed that we can create a good translation engine if we write proper linguistic rules that will transform the content, will analyze the text linguistically, build a linguistic tree, and then choose the correct words to translate. So, but it sounded even like worse in some senses. So automatic translation indicates fact in the strict sense to translate entirely a text thanks to one or several computer programs. Yeah. So thanks is not in the right place here, but it's like grass. So it's like grass can be translated as thanks in some context. Simply the wrong word sense was picked. Yeah. So here, I think different types of problems can be like attributed to these different types of architectures. Firstly, the statistical system was like very good at disambiguating individual word senses. So with one, so instead of grass, so this with one, so was very fluent, and this grass was correctly, the sense was correctly picked up. But the problem was the grammar, the long distance dependencies. On the other hand, rule-based systems were like better at getting the grammar right, but were not so good at picking the right word sense. And then there was this disruptive technology, neural machine translation, which was around since 2012, and now it sounded pretty much okay. Yeah, machine translation refers strictly to translating an entire text into one or more computer programs. So I think this is something which was a problem, especially in early days of MT, in neural translation. And it's still, you may notice it more or less in neural translation, that sometimes it looks on the surface very much well-formed, correct, and but it still contains this mistranslation. So it's not translation into computer programs. Yeah, so it's translation into so using computer programs. Yeah, without the need for a human translator. Yeah, so it's very much in this case a fluent mistranslation of what is said in the original. Yeah, but with time things have been corrected, and yeah, so nowadays since 2020 you have more or less okay translation. Machine translation, strictly speaking, means translating a text entirely using one or more computer programs, so not into one or more, without the need for a human translator. Yeah, so it's kind of getting to the point that it sounds as if it doesn't need any post-editing in general, but you see that it has been a very difficult way to get there. Yeah, so we have some stages where we did not translate correctly or did not translate fluently, but this is like the history of this technology. The fluent mistranslation, you still can find some omissions are still kind of dominant in neural MT, and this is one of the problems because you need a bilingual translator to catch these errors. So you need someone to be able to check the source text and the target text to verify that this is indeed the case. Yeah. So there are some examples of this in some critical domains here. So in human translation, for example, like medical domain, in the human study looking at booster vaccination, antibody levels against these types of viruses remain stable at high level or increase slightly. Yeah. So, but then you're using this cutting edge, translation. So just focus on these types of problems. Yeah. So the issues are that bleiben auf hohem Niveau. Do not follow each other. So there is some gap, and in a medical text, so this gap can be like accelerated, it can be enhanced with lots of terminology. And for neural translation, this can become a little bit confusing, less so for human translator. So human translator was able somehow to bring this together, remain stable at high level or increase slightly. Yeah. But so this DeepL back 2019, so a few years earlier, I haven't checked later on, but I think that there were still problems. So remain stable or increase slightly at a high level, so which kind of says a little bit different thing. Yeah. So it's not remain stable at high level. It says that it increased slightly at high level. Yeah, which can be misleading for some doctors, which again look very nice, very fluent without these major interruptions. So it's kind of the problem with earlier systems, that if the system was not sure about something and could not translate something, you immediately see that there were some issues, some problems, some bells were ringing, and you could like be alerted to these potential gaps. Yeah, so thanks doesn't sound right, so you may see, yeah, it's something that, and these rule-based MT were generally less susceptible to this mistranslation. So if it mistranslated something, something was really wrong with the rule base. So, and rule base were usually verified by human developers. Unlike with modern technology, where the rule bases kind of don't exist, so you don't have control over the algorithm is created from the data. Yeah. So and Google Translate did not do much better at that time. So it said remain stable and increase slightly respectively. So, and this is what you will find all the time kind of as an issue again and again, that actually the systems perform more or less on the same level. So there could be some slight linguistic differences between different systems, but what really matters is the difficulty of the language itself. If the sentence is not well written, if the sentence is ambiguous or contains some linguistic difficulty in itself, like here we have this long distance dependency between bleiben and auf hohem Niveau. So this is in general difficult for the technology, and this creates like lots of problems across different systems. And this is like gives some hope for us, and this will be the matter of our collaborative work, where we will try to prepare the text for machine translation, try to identify these linguistic problems in advance before submitting them to machine translation, and rewrite it into something which is more useful for MT, to design so-called controlled language or machine translatable language, which will have a much better chance of translating things correctly by reducing this number of critical or difficult places in text that could be going wrong. Yeah, so there is this. And so rule-based machine translation, this earlier technology which we looked into. Yeah, so we said that it doesn't disambiguate well individual words, but surprisingly, it doesn't mistranslate this message. Yeah, so in the study essay, so it wasn't sure about studie, whether it's study or essay, so it put both of the booster vaccination and antibody mirrors then against these viruses. So so remain stable on high level, high standard, or rose easily. Yeah, so not easily, leicht can be slightly or easily. So, but it kind of, the message is correct here. So at least there is no such mistranslation which can be omitted, which can misguide people. And very often this distinction leads to preferring these older systems because there is less chance of missing something that is not visible. And people, we will look into some work, into some articles. I'll present some slides which discuss specifically this problem, that you can distinguish two types of errors. One of the types is so-called invisible errors. and this is defined as errors which cannot be found without looking into the source text. So errors which you need to find by verifying that the content of the source message or of the gold standard human translation is exactly the same as the content of the machine translation output. So for some errors, this is not the case. Some errors are so-called visible. So like here, thanks to is visible error because you don't need to look into the source text to say that this is wrong. So some errors are stylistic, so they are not affecting the content, and you can find them like fluency errors, some stylistic errors belong to this visible error class. But actually, neural machine translation is more susceptible to generate invisible errors, and we have, for some tasks, actually the use of this old technology, or maybe repackaging of that technology as post checks for neural machine translation output. Yeah. So another rule-based system, Systron. So in the study, so remained stable. Then there is lots of terminology on high level, or rose easily. Yeah. So easily was still a problem. Steigt leicht an, leicht was a problem for disambiguation, but here it's even more interesting because it still kept this long distance dependency. But because these systems actually built the proper syntactic tree, so there is proper linguistic analysis, it was able to determine that bleiben auf hohem Niveau, so they actually belong together, they actually have like the same link, not in terms of linear relations, but in terms of structural relations, in terms of relation between different concepts. Okay, so just some motivation for where this would lead us. So we need to see the weaknesses and strengths of different types of machine translation systems, and like we try not to work against machine translation, but actually to find a proper place, OMT, in our translation workflow, because in many respects machine translation happens where there otherwise would be no translation at all. So it's not like in competition with human translation, and we have more demand in the machine translation area so than supply in general. So jobs have been kind of more created for translators than taken away by machine translation technology. And it's more about finding the best arrangements of machine translation engines developed by different developers and our company, our team, our individual workplace as freelance translator, and fitting it like more or less into this workflow. And from early days to the big data industry, so this role was changing. For example, nowadays you're using machine translation very often for the tasks which were not imaginable in the past. One of these tasks is machine translating large data sets for machine learning. So you can just machine translate, for example, some annotated data sets for proper names and identify that as a resource for German, for example, which hasn't been developed before. Or, for example, there is a data set for metaphor identification automatically in English, but there is no such data set for Ukrainian, so you can create this data set very quickly with high quality neural machine translation, but kind of being aware that there could be some invisible errors, for example. So whether you need to check where there are some critical points which you need to verify. So, and there is this kind of tendencies that we observe in our industry nowadays in translation. On the one hand, developing better and better system, and in dynamics of what is required by the industry. So we see that machine translation is useful in more and more scenarios. So before it was not very useful for post-editing. Sometimes it was quicker to translate from scratch than to post-edit. And control language was very much in demand, and translation between closely related languages was one of the other success stories, as I already mentioned last week. But Human translation, of course, kind of is regarded as gold standard, but sometimes we translators also make errors, and machine translation can also become a way for us to check our own errors. And then we, as human translators, can check machine translation errors if we know that some expression, some linguistic issue is difficult. And usefulness, of course, increases with time. You may find some old translators who are still skeptical about MT, and we cannot afford to stay skeptical. Of course, it's kind of now important factor. And there are these converging trends. So on the one hand, we require more and more text to be translated. There is this demand for high volume translation, especially for localization, for issues like technical documentation for different devices which are sold globally, for medicine, for pharmaceuticals which are sold like on the world market for different countries. And that translation needs to be done very quickly. The volume is high, so we cannot just do it individually, like as in olden days where the translator could translate, for example, some literature piece for 6 months or the whole year and then submit their own translation to the publisher. And then that was like pretty much the time to move on to the new book for another project. At this stage, we need to produce maybe the same book volume translation within 2 days. And this needs to be done, of course, with this machine translation help of collaborative platforms like Phrase and with the help of machine translation engines. But on the other hand, so the quality of MT is better and better, and we have better data sets, of course. So we have better training materials for machine translation and so on. So we need like to respond to this paradigm. So this large multilingual projects which we are facing, product documentation, movies as well, global release deadlines. There are some companies which require specific style guides. So we not only need the engines to translate well, but also the engines which can be fine-tuned to specific company voice or company guidelines. I mentioned, I think, in the previous course that the partner with whom we worked demanded that their tone of voice, not only in English, but in other languages, I think it was Verizon. So they wanted to appeal to younger generation. So that tone of voice needed to be dynamic, cool. So it should be appealing to younger generation, younger people. And how you do this, like in machine translation, if it by default gives you like some standard boring equivalent, which is like on the safe side, which works for many products, but doesn't work for this specific client. So there are some companies which work with clients for fine-tuning their systems in order to respond to these demands, like with automotive clients, with this company voice and so on. Yeah, so we can submit our own corpus of translations to these developers, and they like improve or adjust the systems for our And then this steady evolution of MT. What we have nowadays, not only improvements in the text quality, but also coverage of different domains, coverage of translation directions, usability of the systems. Previously, no systems offered possibility to update, to use your own dictionaries. Nowadays, DeepL has this feature that you can upload your dictionaries and make your translation more usable, even though there are some issues with it. We'll talk about them later on. And very often machine translation is integrated with other technologies, like we'll look into Phrase. I think there is new version of Phrase released, so we'll work with this new interface, and there is some possibility to implement machine translation application programming interface API. And then, so we work also with offline platforms and so some embedded systems. There are some data sets like corpus, which can be supported. Sometimes if you post-edit, your feedback is integrated into improving MT. And there was big issue with Google Translate previously when they developed something like the workbench for translators. They created the post-editing functionality, but there was small print that actually your suggestions, your corrections are used to improve their engines. That's not a problem if you are like translating a postcard for your grandmother, but if it is a serious industrial user, so they really were concerned that their texts are being used, even no human reader looked into their texts, but Google in the small print acknowledged, actually demanded that this text is used for training MT. And with neural machine translation, actually the data is the algorithm, so you may have some confidential information and ending up like across the internet. So that was again a problem for the using this feedback loop. So nowadays companies like Phrase, who offer MT as part of this API package, they actually use this feedback loop to train your own engine. So there is some small engine which only is available for you, and any text which you like submit there via secure channel is not available to any other user. So it's and if you close the account, it dies on that server. So they actually took this issue of confidentiality, which is demanded by industrial users, very seriously. So that's kind of something which we need. So we need the awareness of tools, resources, and developing it for creating this modern MT and how MT can work with the other bits and pieces of the translation workflow. So what we have nowadays is we can like see that the translation quality responded to these better ways of organizing training procedures. So firstly, the translation was done very much on the word level, then on the phrase level. So there was this equivalence in the database, which were represented more or less local phrases. And it was a huge dictionary of different translation equivalents, and these equivalents overlapped, and you found the best equivalence which was used there. But then people tried different linguistically oriented things like using linguistic syntax. With neural MT, we more or less don't require any linguistic annotations, but it's kind of resolving these syntactic problems on the global level of syntactic structure. But there is a lot of linguistic issues which we can investigate in our course, like natural language processing technologies, recognizing named entities, multi-word expression, disambiguating word senses, using synonyms like WordNet, word sense disambiguation, light verb constructions, linguistic agreements. So we all can test these difficult things, and this was I think your homework for today was to try to come up with some linguistic issues which might be difficult for machine translation. So we'll have some time discussing these problems, these issues. And so we'll have also in this course discussing system customization and tuning for the specific tasks, and evaluating machine translation systems on these tasks, like terminology extraction, data management, domain adaptation, and so on. And very often people like Taos, for example, they position themselves as a company who creates added value by shared translation resources and open source translation memories. So rather than keeping your translation memories confidential, they say that you get better leverage if you share these resources and get the other people to improve your engine with their data sets, and then you share the resources. And even though you can keep the data which is confidential, but the data which is not confidential, so it's better to share. And also there is a development in the under-resourced languages like Georgian or Armenian, Ukrainian. So they still did not have the coverage and the quality which was available for French, specifically English, Spanish, English translation direction. German English was, I think, not as good as French into English due for some structural reasons. So now it's catching up. But with the modern machine translation technologies, so we have this situation where the data set is determining everything. So there is no data like more data. If you have twice as much data, your quality scores improve by constant rate. Yeah, so you double the data, so you have like one improvement in blue score. So you have further doubling in the data, so one more point. And there is this adding data very much is correlated with increasing quality, but for smaller languages, you don't have this luxury of having large intranet collections of text and having the translation databases and so on. So you have different linguistic procedures to improve that quality. So the results was measurable improvements in time, cost, consistency, and fitness for purpose. But also what made a lot of difference was the methods which allowed us to automatically evaluate the quality. Basically, all these improvements would be like leap in the dark if we didn't have a good method for capturing the quality of the improvements, the difference between our baseline, the way how things have been done before. So why was the reason to move away from word-based translation to phrase-based? What was the justification for trying this neural machine translation if we had that? So there was some kind of argument that we have all these rapid improvements through time because we developed some systematic and statistically valid way of measuring the quality of machine translation. Firstly, as human judges, and then automatically. So that was kind of also important topic in our course will be how we systematically organize the experiment to justify this quality measurement, to justify this quality score, and to demonstrate to our team that the quality is there, that there is some threshold where we move beyond what is what can be done like without MT. So where we prove that machine translation is really doing its job and that one engine is doing this job better than the other engine. Yeah, so we will look into this. And people have developed actually formalized frameworks nowadays for capturing this improvement in quality using human judgments, but also using post-editing, using also things like automated scores like Blue and Comet and other automatic measures. So we'll look into that specifically on Phrase platform. We'll try to annotate different error types and see whether linguistic quality assurance score actually gives us this pass rate for the engine. So that's kind of how the technology has been moving and what has been driving these improvements in technology. So this course will also have this research component, and this is very much driven by this job market requirements. Very often when you are in this workplace, your manager, your team will ask you, so we have these like two providers, can you compare these two providers and tell which provider is a better system for us, is best fit for us, how it kind of best fits into the scenarios which we are having here. And there is no one size fits all answer here. So you should be able to organize an experiment in a valid way and show that really there is a statistically significant difference in the scores between the two systems, that it's not simply due to chance that DeepL is better than Google Translate or Bing, but this is really can be shown given the variation of scores which you have. So you can organize this evaluation experiment which is fine-tuned, which specifically targets your your problems. And these research skills are also some skills which cannot be replaced by artificial intelligence. Yeah, so very often we feel that we are in competition with these large language models and these automated agents, and many jobs have been actually, like even customer service response, delegated to the agents, automated agents, large language models agents. But the ability to formulate the question, the ability to see the problem, the ability to understand the best way to demonstrate the usefulness or the difference in quality to the team is something which I think needs this research element, and that's where our course will cover the methods that you can use for research. So basically, as I said last week, we'll cover different bits and pieces like Lego bricks, which you can put together in order to organize this experiment. One way would be to combine, for example, human evaluation scenario, blue, comet, error analysis, and demonstrate that two systems differ in these specific areas where there is specific scores which come as response to this organization for this specific text types, for these specific problems. And the data sets which you can use can be generic data sets, but it can also be your own data sets that you can download or align yourself in platforms like Sketch Engine. So we'll talk about these principles of experiment design. We'll have in-class pilot projects, and your final assessment will be actually a research project like that, an experimental case study, how you measure the improvement in the workflow, or how you design something that would answer a relevant question for the industry. So that's kind of the motivation. So I think we will cover these issues. I think I mentioned this a little bit last week. So it will be machine translation architectures, some unresolved issues in machine translation, post-editing, control language, sub-language, human and automated methods of evaluating MT, so error analysis schemes, improvement of the systems, evaluation based on linguistic constructions or concordances, then measuring the agreement between automated scores and human scores, then customizing machine translation systems with dictionaries, for example, with terminology databases, and training your own, building your own machine translation systems if you want. So there will be like a link to the platform where you can do a machine translation system for yourself, not a very large system, but a system which will produce some baseline translation. Yeah. So ideally, so it should give you some relevant skills and also some intellectual advantage, because one of the intellectual problems of this technology is that Martin Kay once said there will be no good engineering where there is no good science. So if you develop some system, machine translation system, without properly understanding how linguistically so which linguistic issues are relevant for us. For example, if terminology is relevant and the system is not covering terminology properly, so your system will always be as good as your understanding of the problem which you're having linguistically. Yeah, so or long distance dependencies, or some fluent omissions, so anything that we don't understand, and we can get this understanding not through engineering but through this evaluation, through the uptake of the technology by this humanities perspective, by viewing the results of machine translation from the side of translators, of human translators, rather than from the developers or engineers. So of course they kind of can approximate the improvements in quality, but really if something is worse in the new architecture than has been in the old architecture, like these omissions and fluent mistranslations. This could be a problem for some scenarios where we thought it's safe to use machine translation systems. Yeah. So, and I hope that some of these skills could be useful for you for further years of your studies, like final year bachelor thesis, master thesis. Some of you may decide to go further. And the impact component is also important. The potential value of this technology could be not only for big businesses, big companies, which use machine translation anyway, but some stakeholders like charities, non-government organization, volunteer groups, where they actually could benefit from proper understanding, proper design of the workflow, which has machine translation as its component, not simply just using something cool out of the shelf, but designing it properly. Yeah. Okay, so the linguistic difficulties, something which you have prepared for today. So I'll show you some examples, what I found, what is reported in the literature, then maybe we'll come back to things which you found, which you found interesting yourself. So Martin Kay said that history provides no better example of improper use of computers than machine translation. So what he meant, of course, was more relevant in 1980s, but still there is some kind of misconception that one of them is now that machine translation will eventually take the jobs from the translators and will be replaced all by intelligent machines. So that's kind of the trajectory where for the people who don't understand the technology, like from more or less from inside, or did not face these types of errors that you might face in these critical domains like medical domain or technical domain. So this might look as plausible scenario, but basically, so what you face nowadays is that if there is a machine translation error, if there is some mistranslation or some information is missing, yeah. So the machine translation is still an engine. It's not a social agent. So if you cannot sue the developer of machine translation, so they don't take responsibility for these errors. So this like engine which you are using for the risk, for your own risk. So it's provided as it is without any guarantee of the quality. Yeah. So, and basically what this means that you will always need kind of someone to rubber stamp the translation quality, to verify things and to say that, yeah, this is something I take responsibility for. This is something that I acknowledge is correct translation. And it's like with legal translation or court sworn translators that you can translate that document yourself. You may have bilingual competences, but you need someone who takes responsibility for the quality of this translation. So who can stamp your translation and say that this is the correct translation. And this basically means that you will always need, even if in the world of perfect translation, which we're still kind of some distance away, you will need someone with equal competence, someone who knows the translation, the language as deeply as the engine, at least, so who can verify and take responsibility for any errors which you can use. So fully automatic high quality translation, worthy idea, but it may never be achieved. Yeah, so it provides, but it can provide us some understanding for how the language works. So, and it is hoped that the better scenario is like to create this translator's secretary, which will be built with taste by people who understand languages and computers well enough to know how little they know. So the advantage of neural machine translation is basically covering these areas of language which we don't understand well, but which kind of come naturally as a consequence of this interplay between millions of neurons, and maybe that's kind of on the right track. But I think that's still very relevant for us, that we don't work against machine translation, but work in collaboration with machine translation. So what we can reasonably expect from machine translation: faithful, appropriate style, functional, translation, whether these things apply for the machine translation, like human translation has appropriate style. So we don't talk about machine translation quality in terms of the issues which we discuss with human translators. In your translation classes, maybe you covered things like scopus, so you have different versions of the text for different audiences. So you adjust the text in response to the scenario in which the text will be used. So you have multiple different translations depending on the purpose of translation. And you don't talk about this when you are discussing machine translation quality. So you kind of basically still work with this simplification that you have the very good translation goal and you're trying to approach that goal, at least the goal where there are no errors. Yeah. So, and there are some genuinely difficult places in human translation in text, like there is this problem of ambiguity. Yeah. So friend, in some languages you need to specify whether it's male or female friend. Then ami can also mean girlfriend or female friend or just friend. There are some idioms where meanings come not from the text, but from interactions of text and the background information. Like this is the citation from the Bible, so you cannot just translate it in normal way because there is some canonical translation of this piece of language into the target. So the stakes can be that high that you don't have the information within the text, but you need to look outside the text. Yeah, so this may be also difficult for machine translation. So readers share same knowledge in the culture, no terminological problems. Maybe that's where machine translation is the strongest, but you can always find some areas where it's weaker. Yeah. So then we'll see these questions like why it is hard, what is useful for, and then move to these questions, how does it work, and how do you tell whether it's good or not? And at this point, we'll look into these platforms for evaluating the quality of translation. Yes, so Blue will come into play. So now I'll give you some examples of hard, difficult sentences on my side, and then maybe ask for your findings as well. So if anyone just investigated these problems. So firstly, the language is ambiguous, and very often this ambiguity can be difficult for machine translation. The word light, for example, can be different parts of speeches, and in French it can be translated differently. And very often you need like some context to resolve this. So in English, you can say, I like the light. I mentioned this example. And each occurrence requires different translations. So you can test whether DeepL kind of can disambiguate this. But here it's relatively simple to disambiguate because it's clear from the position that the thing coming after the subject is usually a verb. So this is a verbal translation. So allume, j'allume. So things which are coming after the article are noun group, and noun phrase consists of an adjective and the noun. So this should be translated as an adjective. This should be translated as a noun. So it shouldn't be like rocket science for machine translation if you get the structure right. So then you get typical translations for verbs, for adjectives, and for nouns, which kind of will disambiguate this. But sometimes you need like sophisticated world knowledge. The soldiers fired at women and they fell, or the soldiers fired at women and they missed. Yeah, so you need to translate the word they differently depending on your knowledge of the situation. Yeah, so that if someone is fired on, so they could be injured, could be hurt, could be killed, and then this results in falling. And if someone is firing, so one of the possibilities is that they miss and don't hit their so whoever they're shooting at, yeah. So which is would be lucky, yeah, for those who are fired on. So, but this kind of has visible interpretation, and so we can test this like machine translation in this respect, yeah. So then there are some cases where not the word is ambiguous, like they, so, but the phrase, the whole phrase is ambiguous, even though individual words are not ambiguous. So this is like syntactic ambiguity rather than lexical ambiguity. So clever boys and girls go to school. So you don't want, so the word clever refer only to boys. Yes, so clever refers both to girls and boys. Yeah, boys and girls is like one unit, and the adjective clever modifies both. That's so you don't want to translate this into French. So in French, you need like to reverse the order of the adjective and the noun. So habile you should place after the whole group rather than just after garçon. Yeah. So les garçons and les filles habiles vont à l'école. Yeah. So that's, but this not always works like this. So there are some contexts where the priority, so you need like the adjective to modify only the first noun. So this might depend on the actual situation. Pregnant women and children have priority. So you want like first interpretation, you want to move the adjective only one place, not the whole place. So that's kind of, you don't want this translation. So improvements in neural machine translation very often resolves this issue. So, yeah. And it's kind of comparing, Martin Kay in 1980s, comparing this to the difficulty of the challenge. Yeah. So that's kind of my take on these difficult problems. Has anyone found yourself something which is like not working in machine translation nowadays? Has anyone tried to experiment with what?
You mean just in general?
Just in general, so anything which in your experience did not quite work.
Yeah, I think it's all about last like specific phrases in Turkish. Just don't translate it machine, maybe because it's just not up to date yet. Turkish does not work in machine translation, at least not well.
Right. Yeah. So
it's just it's translated word for word instead of like actually getting the meaning across. Turkish isn't a very straightforward language. Just speaking in general, so it just makes it mess up a lot.
So here there are two issues. First issue is that sometimes the structure of the language is quite different from the source. So it kind of may be easier to translate from between Turkish and other Turkic languages like Azerbaijani, for example, or the languages which kind of belong to the same family because of the similarity of the structure. But if you're translating, for example, Japanese sentence into English, very often someone said, I think I gave this phrase kind of in the last course, so you need to put an explosive under the sentence, blow it up, and then catch pieces in the right order and assemble it at the end. Yeah, so there are structural issues which come as a result of some linguistic contrast between the two languages. But second issue might be like more monolingual and more reflecting the nature of the difficulty than if you translate from Turkish into any language will come up. And this, maybe you're referring to this like idiomatic nature of the language, where the meaning of the whole is not the sum of the meaning of the parts. So you cannot recompose the translation of the whole as simply concatenation of translation of parts. Yeah, so, and that might work kind of by rephrasing it into something which kind of more plain, more so less idiomatic and more word for word. So I think I have here the link here to in our high box. So in this week 1, so I put this week 1 task. So have a look and maybe you can find some examples actually where things don't quite work. So to explore these are chapters which kind of cover more or less background of usefulness of machine translation, different scenarios, different concepts, and so on. And then which things which I ask you to experiment with is to test machine translation to destruction. So come up with some hard sentences and see what actually doesn't work and what actually could work better. Yeah. So for your languages. Right. So that's kind of this part. Then I would like you to, I think now I will move from this issue, so we'll look into some other issues later on, but I will go into the issue of evaluating the translation quality. So there are some linguistic issue, transfer systems, multilingual, so lingual system. Yeah. So how do we tell whether machine translation system is good or not? I think it's, so we better cover that like later on after we cover the slides. But I just will firstly speak about this general intuition. So you may realize that there is some internal problem in, so evaluating the quality of translation is unlike anything else. Like there is a correct way of spelling certain things. So you can immediately spot an error in a spelling error, grammatical error. So if you see something, so there is a script which underlines you the problem with your sentence. Stylistic errors might be more difficult to catch, but there is a way of telling by native speaker that your sentence actually doesn't make a stylistically well-formed piece of communication. Yeah, but what about the quality of translation? Yeah, so you very often like in this gray area where you can do things better, but it's not exactly an error. So you don't have a gold standard for all the translation. In fact, if you are translating a sentence and you give this sentence to, let's say, 10 translators, something which we have done before. So we can carry out this experiment maybe next week, but you will get, even for a short sentence, I think where we got some difficult sentence, was at least 8 distinct variants of translation. So you expect the translation variation even from people who do it professionally. So even if you get 2 exactly the same translation, you start suspecting that this is plagiarism, that this is like not independent translation, and that's kind of start to be a problem. So how do you tell that machine translation is doing its job right? Yeah. So I will show you the script, which is kind of takes very basic idea behind the concept of translation quality, and it's available here in our Moodle space, and you can go straight either through GitHub or straight to this Collab environment. Collab environment will take you to the virtual computer in the cloud on Google servers. Basically, Google pays for electricity if you run anything like machine learning on this platform. So Blue doesn't take much of the impact, so we're not damaging much climate. But if you click on the link, this link, or go via GitHub and click on this link, open in Collab, so it will open for you the copy of this code, which you see in the collab, and this code will be available to run in the cloud-based machine on Google servers. And you may see how much resources you are getting. So, and very often it's more than you have on your laptop. So it's 12 gigabytes of RAM, 107 gigabytes of disk space. So you get this as a standard. So I think in the free plan. And very often you can request, I think, even some more advanced resources. So you can request GPU, so to run some machine learning things which we'll not be using today. But you can run simple code, which you can also run on your machines. But the advantage is you don't need to install anything. Google engineers installed already everything which is needed to run this Blue script. And Blue script basically is, so it explains here what it is. So it's bilingual evaluation understudy. So it's a way of automatically calculating what kind of it deems to be translation quality. Yeah. And the idea behind this is that it takes the gold standard human reference translation and assumption that the closer machine translation is to this gold standard human reference translation, the better it is, right? So that's kind of naive, but we'll see how well it works in our course. But now just let's try to run it like without like believing that it's doing a good job. So all you need to do in this case, so on your laptop, so if you log into Google account, so go to this Colab link, so it will open with this, and then you can open this Dateien, so or whatever, so link, and it will create for you this virtual machine in the Google Cloud. And you will be even able to upload your own text. So the text which you would like to evaluate for the quality, for the machine translation output quality. So you will be able to upload this text here. So it gives you some strings which you can evaluate as strings, but so you don't have to have it on text. So it kind of to make sure that this evaluation script runs without any additional uploads. Yeah, so just to make sure that it works. And then this is like the interface which we are getting. So it doesn't look like your computer. So what you are getting is called Jupyter Notebook. Jupyter Notebook is a way of displaying for you the code and the comments for this code. The comments are usually go into this so-called text section, and the code which you can run go into code section. And the difference between them is that code like looks like this, like grayish, and you can always add a new cell which is either code or comments and type your own code. This link which I gave you actually contains someone, so the code written by someone else, but you don't get the actually the link itself. You get the copy of that link. So, and you can modify it as long as you are playing around with it. So it's your own copy. You do not interfere with anyone's work. Yeah. And then what you can also do, you can save this. I think there is a way of saving this code in your Google Drive. Yeah, so I will try to see where it is. So I don't see it now, but yeah. Oh, okay. So you need to open the menu, and if you do any modification, for example, I want to add the piece of code which will not only process individual string, but which will also take the file for me. So I need to convert the file to the format which will be evaluated. So I will save my data as a file. So I need to add some code, and this code will be like my own piece. So I Googled for this code, and I, for example, want to insert this method, so reading file as a string. So I go to this piece and I insert it, and oops, I think that's wrong. So I copy this and I can insert this in this section, yeah. So, and then I can run it as a code. And then to save it on my, so all my work can be saved, I can save it on my Google Drive. And then you can copy it from the Google Drive, yes. And it will be your own copy, so your own work. So this kind of gives quite a lot of interesting ways how you can work with evaluation, save your evaluation results, come back to them, report them. So let's try to run what we already have. So first it downloads this blue script. So yeah, and we'll see how it warns us that Google didn't write this code. So we downloaded the package, so translate blue score. So everything which is needed has been downloaded. Then this is my piece. I kind of skip it for a moment. And then I have now something which I would like to evaluate. And this evaluated piece is, there are two, so we said that we need a gold standard human reference translation. So let's say that this is our reference. Yeah, so there are two references. So reference A is she read the book because she was interested in world history, so English sentence. And the machine translation output hypothesis was she read the book because she was interested in world history, so exactly the same. And there is another gold standard reference. She was interested in world history because she read the book. Yeah, so it says something different. Yeah, so it's kind of here. So if the assumption that the closer machine translation is to the gold standard, the better it is right. So this comparison between reference A and our hypothesis should get higher score than comparison between reference B and hypothesis. Yeah, so if the reference is something else, so notice that we do not use the source language. So we work only within English. We compare English with English. So it's only within one language. We don't use in this stage any translation. So it just simply compares. And basically it's like plagiarism detection software. So people are using this for plagiarism, but it's like testing whether it kind of passes the threshold for the overlap. Yeah. So and closeness is measured in terms of lexical overlap. The more words are the same, the better is the translation. But it does it a little bit cleverer than that. Yeah. So it's not only the number of words, but also you need like some syntax. You need some organization of the structure. And there is very straightforward and primitive way of capturing the structure. So they count how many word sequences are the same. And by word sequences, they mean these two word sequences. She read. So here, she read is there, but she was is not there. Yeah. She read the book, and then read the book. So kind of when growing up to certain amount. Yeah. So let's read these strings into memory. So it splits it. So it read so this sentence as a hypothesis. So actually we can see how this sentence look like. So I ask the system to type this hypothesis, and it kind of breaks it into individual words. And then it will compare the words, but it also will compare the word sequences. Yeah. So now I'm asking the system to score the hypothesis against the first reference. So what you think should happen? So there will be exact overlap. So blue is designed to produce the score in the range between 0 and 1. 1 means that there is absolute plagiarism, there is absolute coincidence of the reference and the hypothesis, and 0, there is no match at all. Yeah, so for reference B, we expect that the score will be lower, and but also blue is designed in a way that it's not only allows you to measure the distance between the gold standard and one reference, but it allows you to measure the distance between the gold standard and a number of references. So the idea was that, yeah, we expect some legitimate translation variation. And there will be lots of people who paraphrase this differently. So if you ask several translators to produce the translation of this document, so you can then penalize the system if it produces something which no one in the cohort of translators produce. So if it finds something which no other system produced, so it kind of generates this score. So it measures the difference to reference A, it measures the difference to reference B, but you can also combine the references and measure the difference, so the distance between the hypothesis and several references. So let's try to run it. Yeah. So you see that that's what we expected. For hypothesis and reference A, we have exactly the same, like 1.0. Blue score is like maximal. Reference B, 0.74. Yeah. And with multiple references, so it takes the closest reference. Yeah, so it also is 1.0. But then what you can also do, and what I encourage you to do to understand Blue a little bit more, so to play around with these scores. Yeah, for example, here you have like one of the possibilities, like the cat was sitting on the mat, or the fat cat was sitting on a big mat, and hypothesis is like the fat cat was on a small rug. Yeah, so how this will go. Yeah, and here another hypothesis on a big, oops, it's here. So I would like to have it. Yeah, a big cat is sitting on a big rug. Yeah, so running this and then checking the scores will be fun. So here you see that there are already the difference between. So the reference B is closer, so 0.72, and 0.75, so it's the difference to the closest. Yeah, so you can integrate several references. So for the next time, so in 2 weeks, please try to make sure that things are working for you for the sketch engine. Things are working for you for Blue, so that you can calculate the Blue scores for you, and then we'll also try to test some engines and give some examples where you find that machine translation systems did not perform well, where they created some errors. And then in the class in 2 weeks, we'll try to see whether we can capture these errors by doing this Blue evaluation. Yeah, so we'll try to see whether the legitimate translation variation and the Blue method allows us to identify any gaps in translation quality on the sentence level. So at the moment, so please try to come up with some examples where machine translation systems made errors. Right? Any questions in this point? Right.
Regarding the task we have to do at home, do we have also to submit it?
We will discuss it in class, so no need to submit it. Just have your examples ready, so maybe we'll have a few minutes just to upload it so we can try it on the screen. But also you're encouraged to try it with Blue and see whether things are captured by Blue.
Should we decide to try it, do we have also to write those kind of codes, or?
No, I think here all you need to do in your code is to change the hypothesis and references. So play around. Sometimes you just may leave this empty, but just please leave the score. So, but every time you change it, run this cell, run this code, then variables are, and then here the score is calculated. So 0 is, but because that reference B was empty, but this is like the score for that one hypothesis, right? Okay, so I hope this was useful, and if no other things, so we'll see each other in 2 weeks.
Your email
Should work. You sent me an email earlier, right?
Well, I have last week.
I was away at some point, so maybe I just missed emails. So they should. But yeah, they can come to my office as well. So 050. I will be away from afternoon tomorrow, coming back on Friday the following week. So I will miss like 1 week or so. But yeah, I will. I think I did not respond to some emails. Some health reasons, so in the family, so there were overwhelming things that yeah, just if there is anything urgent, so that they can resend an email or just come to my office or catch me after class. So I'm teaching Tuesdays and Wednesdays until 12. Tomorrow I don't have office hours. I should have office hours. I have office, so I'll try to respond. Okay, thank you. See you in 2 weeks. Next week. Yes. Oh, sorry. Yeah, I kind of did not have time. So yeah, I'll maybe send in. The problem was that I think it was difficult to retype all those emails. So I waited until we have the Moodle space. So I hope now I will send any information via Moodle. So, but I will send also the link to the this homework for the Moodle and also the recording.
Do you need a license, or can you just import the API into Python?
For this script,
Yeah.
I think it's like an open source, so open domain, so they explicitly put it for everyone. I think GitHub, most things are open code. And you have the link from GitHub, like open in Collab, which kind of opens automatically.
Yeah.
But that like is directly linked to Collab, so it's kind of assuming anyone who put that code online wants others to copy. Yeah.
In the import header, there was like an import for the Blue engine. Import. That's where you import like the whole imports.
Okay.
Whatever you need, what's not provided in the...
Blue is like in open source since 1990, so there is kind of so it's not proprietary. So it's like code is published since 1998, I think. So, but most of the things in natural language processing is open source. So
that's interesting.
Kind of quite like.
Did you see Python's print? Just print.
JavaScript is even better. What is it? See out.
Oh, come on.
Surprised as well.
You can also dynamically type it.
You
don't have to say like public int whatever. You can just say.
Oh my God, that's like what we
Are you here tomorrow?
Yes, I'm teaching from 8:30 till 11:45.
Do you have a key that fits into 014?
14, I haven't.
Do you have a
tried it,
general
but
one?
I have a general key and it works for most doors, so maybe.
Okay,
It's up to you.
could you open the door for me tomorrow morning?
Yes,
Yeah.
I will do so.
I just dropped by and
You mean the very
First
first one,
yeah.
so